Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be looking at how to compare quadratic functions. The question reads, which statement is true about functions f of x and g of x given below? All right, so function f of x is given as an equation, f of x equals negative x squared minus 4x minus 4, and g of x is given in a graphical format. All right, so we're going to be comparing both of them, but if we look at the comparisons here, intercept roots, when they're equal to each other, minimum value, it's beneficial for us to have both of them in graphical format in order to carry out our comparisons. All right, so what we're going to do is we're going to go ahead and graph f of x on the same coordinate system of g of x. We're going to graph it here, and then we're going to carry out the comparisons. You're allowed to use a graphing calculator for this problem, so you can skip this part that we're doing. We're going to assume that we don't have a graphing calculator and do it manually, all right? And then when we're done generating the table, the graphing calculator can give you the table, and then you can use it to construct the graph, all right? Okay, so let's go ahead and graph f of x. So to graph f of x, we basically just need the vertex and then pick 2 points before and after, to the left and to the right of the vertex, and that should suffice. Okay, so to find the vertex, the formula that we're going to be using for the vertex of f of x is negative b over 2a for the x coordinate of the vertex, and f of negative b over 2a for the y coordinate of the vertex. Okay, so the function under consideration is negative x squared minus 4x minus 4. So we can easily determine what a, b, and c are since it's already in standard form, right? So a is going to be negative 1, b is going to be negative 4, and then c is going to be negative 4 also. Okay, so let's write those out. So a is negative 1, b is negative 4, and c is negative 4. We need all these because they can help us find the vertex. All right, let's start with the x coordinate of the vertex, which is negative b over 2a. So we just substitute. We get negative 4 over 2a, 2 times negative 1. We're going to simplify this. We get 4 over positive 4 over negative 2, which is just negative 2. The y coordinate of the vertex is the function evaluated at negative b over 2a. Okay, so we already know what negative b over 2a is from the first part, which is negative 2. So we're looking at f of negative 2. So what we're going to do is simply plug in negative 2 into all the x's in the function. If we do that, we're going to have negative 2 squared minus 4 times negative 2 minus 4. Simplify that. Negative 2 squared is 4, and you have a minus negative 4. Minus plus 4 times 2, 8, minus 4, 0. Okay, so what does this tell us? It tells us that the vertex of this function is going to be a sad parabola, right? Because a is negative, it's going to be opening down, but the vertex, or the highest point, is going to be negative 2, 0. All right, so we're going to generate 2 points before and after this vertex so that we can have a nice looking graph. Okay, so let's create our table of values to help us find this out. All right, so let's go put our x right here. So we're gonna use the middle term. Oh, let's do this so it's easier to see. So 1, 2, so that's 2 before. And then we have the actual vertex, and then 2 afterwards. That should suffice. Okay, so remember that parabolic curves are symmetric about the vertex. Okay, they look exactly the same. So the output values that we're going to be getting before and after should match. That's an easy way for us to check. Okay, so negative 2 is dead at the center. We're going to pick 2 points before, negative 3, negative 4. And then 2 points after negative 2, which is negative 1, 0. All right. All right, so let's start with negative 4. So we have f of x. The function is negative x squared minus 4x minus 4. So if we do f of negative 4, just plug in negative 4 into the function. Minus 4 times negative 4 minus 4. Okay. If you go ahead and work this out, your output value will be negative 4. That will be your f of x or your y. Okay. And then if you plug in negative 3, negative 3 square minus 4 times negative 3 minus 4. So if you work that out, negative 3 square is 9. Negative 9 plus 12 is positive 3. 3 minus 4 is negative 1. Bam. All right, so for negative 2, we don't have to do it because we already did it earlier. F of negative 2 is going to be 0. We did it right here, okay? Okay, and then we're going to expect the symmetry to start showing up. So this one should be the same as that, and f of 0 should be the same as negative 4, okay? So f of negative 1, just plug it in. Negative 1 square minus 4 times negative 1 minus 4. And if you work it out, you have negative 1 plus 4, which is 5. 5 minus, wait, so we have a negative 1, and then this is minus 4. So that's going to be negative 1 plus 4 is positive 3. That's 5. Positive 3 minus 4 is negative 1. Bam. Okay, so good. That matches. And then f of 0, that should be easy to do. Negative 0 square minus 4 times 0 minus 4. Okay, 0 square, negative 0 minus 0 minus 4 is just negative 4. Excellent. So we see the symmetry showing up there. Okay, so we have a table of values that we are going to be graphing in this on this system right here, and then comparing it with the already graph function g of x. All right, so x and f of x. We have negative 4, negative 3, negative 2, negative 1, 0. Just putting it together so it's organized. So we have negative 4 goes to negative 4, negative 3, negative 1, 0, negative 1, negative 4. All right, so let's graph it using blue. So the vertex first, negative 2 zeros right here, bam. And then when we go to a negative 3, it's down to negative 1. Negative 4 is down to 1, 2, 3, 4 right there. And then negative 1 goes to negative 1. You see the symmetry forming, right? Symmetric about the axis of symmetry, x equals negative 2. And then 0, negative 4. Bam. Okay, so let's graph the function. There goes our nice little parabola. This one that we're drawing right here is f of x. Okay, now we're in a position to compare. First question, or first option, the minimum value of g of x is greater than the maximum value of f of x. Okay, so we just figure out what g of x and f of x are and then compare them together. All right, so for option 1, the minimum value of g is basically the smallest, the lowest point. So look at g of x. This is the lowest point right here for g of x. 1, 2, 3, 4. So g mean is negative 4. That's the lowest point, and the highest point is the peak of f of x. F max is the peak of f of x, and the peak of f of x. Remember, you're tracing it to the y. Okay, the peak here is 0. So the minimum, the value of g of x is negative 4, the lowest point, right? And then the maximum of f of x, the peak, is 0. So this one says the minimum value of g of x is greater than the maximum value of f of x. So is negative 4 greater than 0? This is false. Okay. The minimum value of g of x, we can see, is lower. The value of g of x is lower than the peak of f of x. All right. So the minimum value of g of x is not greater, is actually less. So option 1 is wrong. All right, so let's move on to option number 2. It says f of x and g of x have the same y-intercept. So let's go ahead and find the y-intercepts of both of them. Remember what the y-intercept is? That is where the graph cuts the y-axis. So the y-intercept of f of x is negative 4. Negative 4 right here. Bam. There goes the y-intercept of f of x. And then what's the y-intercept of g of x? The y-intercept of g of x is where g of x crosses the y-axis, which is exactly at the same point. Ladies and gentlemen, we have a winner. This statement is correct. The correct answer is option number 2. All right, so let's just go over questions 3 and 4 just to review points of intersection and roots. Let's look at option 3 just to show you why option 2 is the only correct answer. For option 3, it says f of x and g of x have the same roots. So what are the roots of a function? The roots of a function are the points where the function, the x values where the function intersects the x-axis. Those are the roots, okay? All right, so for f of x, let's put that in blue. Roots of f of x, they are the points where f of x hits the x-axis, okay? So if you look at f of x, you have a double root scenario right here. The peak touches the x-axis at exactly this point. This point right here is negative 2. So that's the root of f of x. So the root of f of x is f of x are x equals negative 2 and x equals negative 2. This is called a double root scenario. Or you can say x equals negative 2 with a multiplicity of 2. All right? So the roots of f of x are negative 2 and negative 2. They're the same. They have exactly the same root. Okay? That always happens when your vertex is the x-intercept. Now let's look at g of x. The roots of g of x are the x-intercepts. So what are they? The roots of g of x are x. The one on the left is negative 2, which matches f of x. But how about the second one? The second one is 2. All right? F of x equals negative 2. I'm sorry, x equals negative 2 and x equals 2. Those are the roots. Do these two match identically? The answer is no. They're not the same, okay? G of x has a root. That's not the root of f of x. The only root of f of x is negative 2, whereas g of x has 2 distinct roots. So their roots are not the same, and that means that statement 2 is false. Not the same roots. Statement 3 is false. All right, so for option number 4, it says f of x is equal to g of x when x is equal to negative 4. Is that true or false? So what we just have to do here is plug in negative 4 into the two functions and compare them. All right, so let's start with f of x. So with f of x, we're going to try to figure out what f of negative 4 is. Plug in negative 4 into the blue function. If you plug in negative 4 into it, already did it right here. If you plug in negative 4, you're going to get negative 4. Bam. Okay? And then g of x, you do g of negative 4. Plug in negative 4 into g. If you plug in negative 4 into g, 1, 2, 3, 4, your output is going to be up here. Bam, which is 1, 2, 3, 4. It's going to be 4. Okay? So are these two the same? The answer is no. Negative 4 is not equal to 4. So this statement is false. So we can clearly see why option number 2 is the correct one. All right, the intercepts of both functions are exactly the same. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel. I posted a comment in the comment section letting us know what you think of this presentation or if you have any questions. Tons of support resources can be found at mathgotserved.com to check it out. Thanks again for watching, and we'll see you in the next video. Goodbye.